Welcome to the third and final tutorial on Flexcom's user interface. My name is Angus Connolly and I am the product manager for our Flexcom software. In the first tutorial I showed you how to input data via Flexcom's keyword editor or by the table editor, which is just an alternative view on the same input data. I also briefly introduced you to the model view component. Then in the second tutorial we started speaking about the file view component and how you could actually start running simulations from the file view and actually monitoring their progress using the analysis status view. So in this tutorial I'm going to take a little step back now, and before you would run a simulation in Flexcom, what QA checks would you like to do on your model, and how does Flexcom's user interface facilitate those checks? So there are a number of options here under the view menu. So there's analysis preview options. So let's quickly look at, say, the REO response plot. This is a nice feature which lets you plot REOs in 3 dimensions. Let me just resize that so we can see it a little bit more clearly. Make that full screen, and I'll just hide the model view now for the moment, and perhaps I can even just hide this file view and the analysis status view. So this is a 3D plot, which we can, the commands for 3D plotting are fairly straightforward. You can use the right mouse button to move the plot around on screen. You can use the left mouse button to spin the plot around. If you do something silly and you get lost, you can just press the zoom all button. So what we have here is a response for heave REO in terms of meters per meter. So meter heave response per meter wave amplitude as a function of wave period and wave heading in degrees. So that's heave. We can also look at surge, sway, any of the other degrees of freedom. If it's a 2D model, it'll be usually heave, surge, and pitch you'll be mostly concerned with. And this is a nice graphical way of looking at your REOs. You can also look at those in 2 dimensions as well if you prefer. So you can plot, you can exactly interrogate, a typical pitch response there. You can pick off your period and look at what the response is. That's just to check if you have your input data as you expected it. So kill the versal REOs. Just open the file view again because I'd like to just open a regular wave analysis now as well. So let me just look at another option, which would be to preview what the water surface elevation is like. Again, I need to make this full screen so you can see it a bit more clearly. This plots the water surface elevation as a function of time, and because it's a sinusoidal, it's just a regular wave simulation. It's quite straightforward. You can actually change the point in the wave field at which you're looking. So in terms of Flexcom's model view, the origin is defined as 0, 0, 0, so you can see the origin. It's a bit difficult to see the axis there on screen, but the origin is usually there. So the origin would be like at 0, y, 0, z. So that's, if you want to look at the wave elevation at that point, it'll be 0, 0 in this command. If you want to put in something else like 20 meters away, then you'll see a phase shift in the water surface elevation. The next logical step from looking at the water surface elevation is to actually look at how the vessel responds as a function of time to the wave excitation. So at the moment we're looking at the heave response in meters as a function of time. We can also look at surge or pitch or any other degree of freedom we want. We can also, so this by default is presented at the vessel reference point, which is the point on the vessel at which the REO data is defined in the vessel keyword. This is normally the center of gravity of the vessel, but you can also put in some offset terms. So if you know the physical separation between the vessel's center of gravity and, let's say, the vessel hang-off point, maybe you can type in some offset values there to take you to the correct location, and the response plot will update automatically. So you can look at the heave response of the hang-off location, which will include the physical separation between that and the reference point. So they're very useful. So for example, you could look at the heave response of the vessel and compare that to the water surface elevation. So you can see where the wave reached its maximum height and what is the phase shift between that and the vessel motion. And it's very useful as a spot check if you just want to do some basic hand calculations on your REO data before you start the simulation as well. The vessel, the water surface elevation, that for a regular wave and a random sea analysis, that can be even quite useful because you can isolate peaks in the water surface elevation, and perhaps you want to do a screening study where you just do a random sea excitation just in the vicinity of that maximum peak or the maximum vessel motion. if you like. If we were to just look at the final preview option, there's a wave spectrum option as well. In my case, I don't really have a wave spectrum because it's a regular wave keyword, but if I was to open up the random wave keyword, I do have a Pearson Moskowitz spectrum. So if I go back to the spectrum plot, you can see that there. So they're the vessel preview options. There are a number of other options in Flexcom which can be quite useful. So for example, I switch back on the model view, and I can turn on this element inspector window, which is an additional window which accompanies the model view. Let me close some of these other windows just to give you a little bit more room to view. Pop the element inspector in the middle. View my file view. Let me just bring up the keyword as well, so it just displays the model for you. Okay, here we go. So the element inspector is quite a useful tool. So I could zoom in on a particular element on the model, and I can perhaps click using the control key. So I hold the control key and then I click with my left mouse button. I can identify any element. Once I've selected an element, the element inspector shows me what the element properties are. So it's just a useful QA check. You can look at wet and dry weights and so on and so forth, internal fluid properties, element diameters, all that kind of stuff. If you'd like to check your finite element mesh density, there's the line generation report. So this allows you to check all of the elements in the model, what their numbers are in terms of the internal numbering scheme, what the element lengths are. So you can just, you can check your meshing scheme. It's very easy to check your meshing scheme by just visually inspecting it as well, by just turning on the node numbers, for example. But this just gives you some more in-depth information into the element lengths used and how they transition between different sections. So you can zoom in on a particular element number and you can find that element number in the list. You can also copy this and paste it into Excel if you want to do some hand calculations. So I'll just close the line generation and the element inspector. Let me see what else I can show you. If we don't have any nonlinear properties here in the model, if we had nonlinear stress strain curves, we can use this input values graphs option to check those out. Parameter values. So you recall that in the static simulation, I might have defined a range of parameters. So like I've got, for example, I have done some calculations here in terms of buoyancy forces. I've done some hand calcs, and I can just hover my mouse over them to see what the results of those calculations are. But if I wanted to just get a summary of all of the parameters I have in the model and all of the values, just for QA purposes, I can look at this parameter values window. Again, this can be copied and pasted into Excel if you want to do some hand calculations of your own in Excel, just to double check what you've done in Flexcom. At this stage, I think I've covered the vast majority of options in the user interface. So let me just walk through the remaining menus just in case I've forgotten anything. In terms of model building, we have two ancillary modules. So normally with Flexcom, you're doing all your model building in the keyword or table editor, so you're actually typing in inputs as you go along. But we've recently actually introduced two new modules which make it very easy to construct certain types of structure. So these are called Flexcom Wind and Flexcom Wave respectively, and they open up different interfaces for wind and wave simulators respectively. So these would look and feel a little bit different to Flexcom itself. I don't know if I've got a sample model that I can show you here possibly. This is the OC4 floating wind turbine. Bear with me while the project loads. The model view, so let's just zoom in a little bit on that. So here we have a floating offshore wind turbine, and you'll notice that this layout of Flexcom Wind, it's quite tabular. It's component based. You define blades and tower and floater and all that as different objects or different components in input deck. And what happens then is when you actually push the run button in this simulator, it actually reverts back to Flexcom itself. So really what this module for Flexcom Wind is, it's really a convenience for making a Flexcom model of this type, and you eventually end up with all of the same keyword options that you would do in Flexcom itself. So I won't dwell more on there than just to make you aware that it exists, and I'll you can view a separate tutorial, more detailed tutorial on Flexcom Wind itself. Also, there's a similar module for wave energy converters called Flexcom Wave, just analogous to what we've seen, just looking at wave energy converters rather than floating wind turbines. The seabed profile generator, this is an ancillary tool which is very useful for creating 3D seabed, arbitrary seabed topographies. So you can actually import a cloud of data points in 3D space, and Flexcom will wrap a 3D surface around that. So I'd cover the usage of this module in a separate tutorial, but for now I'll just make you aware that it exists. In the model we're looking at on screen here, it's very simple seabed, just purely flat. In reality, you would have some more arbitrary variation in elevation as a function of horizontal distance. The hydrodynamic data importer is also a very useful tool. It allows you to import vessel characteristics like REO data, or indeed results of a radiation diffraction simulation like radiation damping and added mass matrices as a function of frequency, and indeed force REOs and low frequency second order drift effects via quadratic transfer functions. So you can use any of these third party products. Aqua and Wamut are very popular commercial products. Nemo is an open source tool, and we hope to add more of those types of products to the list here. So basically you select the product that you've done your hydrodynamic simulation in, then you simply select the output file from that particular program. In this case it's ANSYS Aqua, so you search for a .lis file which is generated by that product. Once you find the file you're looking for, you click open, and then you just hit the run button, and what that does is it takes the outputs from the ANSYS Aqua file and creates input files for Flexcom in the order and convention that it expects them in. So every product would have its own conventions in terms of REOs, say for like vessel headings, are they using radians or degrees, is the phase convention lagging or leading, and so on. So it takes away all of that effort from you and automatically converts the data into the format that you require. If you need some help, because sometimes they ask for some inputs, some basic inputs, you can actually navigate to your ANSYS Aqua in section of that help, and will tell you exactly what it's doing in terms of the conversion process, what it takes from the ANSYS Aqua file and how it converts that into Flexcom. So let me just close that down again. So the hydrodynamic data importer is a very useful tool, particularly if you're doing a coupled analysis simulation. So there are some tools here. These are really not for new users. These are for existing users of Flexcom. If you've been using Flexcom for many years and you've been using older versions, we have a number of tools which can bring your files up to date and compatible with the new version. So the Flexcom settings menu, which is just really for advanced settings. You probably won't really go into this in any great level of frequency, but just to be aware that it's there. If you need to change anything. As I said before, the reset user interface layout is a very handy button. If you lose a window, you can just reset the layout to the original layout. Licensing, again, that's just, you don't need to worry too much about that. Your IT personnel will set up the Flexcom license for you. Finally, the help menu. Well, we've seen the help menu because we've looked at it a few times already. A number of these tutorial videos, which you're actually watching one of them at the moment, and then the list of example projects, which is very helpful. So you can look at different types of riser system, and then pick out, if you're developing a new project, you can probably look at one of these existing projects, which will give you an idea of how to create that type of structure in Flexcom. So that concludes the tutorials on Flexcom's user interface. I'll go into more detail in terms of the model view, maybe the seabed profile generator, also the plotting module in subsequent tutorials. But from these opening tutorials, you now have a very good, or you should have a very good understanding of the UI of Flexcom, and you'll be more than capable of working with it and getting the most out of it. Obviously, you'll get more proficient with more practice and the more work you do with Flexcom. So I hope that you can join me in subsequent tutorials where we'll go into more detail in terms of model construction, running simulations, extracting results, looking at more detailed topics. So the more videos that you watch in these tutorial series, the more detail it will go into and the more advanced topics that we'll begin to cover.